Hi everyone, it's Miss Costa here, and in this video what we're going to look at is how to find the hypotenuse of any right angled triangle, and the way we're going to do that is by using Pythagoras. So let's find out what Pythagoras' theorem is. Okay, so the first thing that we need to be really comfortable with doing is identifying the hypotenuse of our right angled triangles. Now, the hypotenuse is just the name given to the longest side of the triangle. And the longest side of the triangle is always going to be the one opposite the right angle. So when you've got a right angle triangle and you're trying to use Pythagoras, look for the right angle and identify your hypotenuse. That's the most important thing that you can do to begin with. So over here, that's the side that's opposite my right angle. So that would be the hypotenuse, okay? And the hypotenuse, that's how we spell it, hypotenuse. It just means the longest side. Okay, so the hypotenuse is the longest side of any right angled triangle. And as you can see here, that would be the hypotenuse here, that would be the hypotenuse here, and that would be the hypotenuse here. So sometimes they might be drawn like upside down. Always look for the right angle, and the hypotenuse is the side opposite that. It's the longest side. Sometimes it's not really clear because diagrams might just be sketched. So let's see if you can have a go at identifying the hypotenuse of these triangles. Okay, so let's have a go at finding the hypotenuse of these right angled triangles. Remember, the hypotenuse is the longest side, the one opposite the right angle. And here are the answers. It helps sometimes to draw an arrow from the right angle to the side opposite to it. So it's always going to be the side opposite the right angle. Now, what Pythagoras discovered is that, well, it's debated as to whether or not he discovered it, but it's Pythagoras' theorem nonetheless. So what he discovered is that if you create squares on the sides of your triangle, so over here I've got a side length of 3, and if I created a square, the whole point of a square is that it's made up of equal sides. So over here, if this was a square, I'd do 3 times 3 to work out its area, and that would give me 9, or I might say 3 squared. Okay, so to work out the area of this triangle, of this square, I do 3 times 3. So that area here would give me 9. Now, if I had this side here, which is 4, and I created a square, that would also be 4 because squares have equal sides. How would I work out the area of it? I'd multiply base times the height, 4 times 4, and that can also be written as 4 squared, which would give me 16. Okay, now this is true for absolutely any right angled triangle in the world. Whatever the area of the squares formed by the 2 shorter sides are, they will always add up to make the area of the largest square. So I don't know what this side is, it's just x. My task is to find out what its value is, but I do know that this is a side length of 4, that's a side length of 3, and I know if I created a square using these sides, that would be an area of 16, that would be an area of 9. Now, what Pythagoras says, or what Pythagoras' theorem says, is that a squared, so the side length a, 4 squared, which is 16, plus b squared, b is 3, and it doesn't matter whether you write 3 squared plus 16, sorry, that's supposed to be 9. It doesn't matter whether you write your a as a 4 or as a 3, because they're both being added, so you're going to get the same answer anyway. All that matters is that a and b are your 2 shorter sides, and that's why we have to identify the hypotenuse, because the hypotenuse, the longest side, is always going to be your c in the formula. So the 2 shorter sides, a and b, their squares are going to add up to make the square of c. So here we've got 16 plus 9, and we know that gives us c squared. Okay, so I've just substituted 4 into A and 3 into B, and that gives me 25. Okay, so I know that, I'll write it here, 25 equals c squared. So the area of this square here, 16 plus 9, gives me 25. Okay, I add the area of the two smaller squares. 16 plus 9 is 25. Now, I know the area of this square, and if I know what the area of a square is, I need to do something called the square root to figure that out. Because I know over here, I think to myself, okay, this square has an area of 25, so something times by itself must give me 25. Hopefully, you're familiar with your square numbers and you recognise that 25 is one of the square numbers, and the square root of 25, this is how we'd write it, is 5. Okay, so once you've found what the area is of the largest square, you square root it to find the length of the side. So in this case, 25 is c squared, so the square root of 25 is 5, so therefore c must be 5. You can try this yourself. You can draw a right angle triangle with a side length of 4, side length of 3, and measure it to see if it is 5, and it will be if you've drawn it accurately. So that's our first example. A lot to take in, so we'll do it again with some different numbers, and I'll also show you how to use the square root button on a calculator.
So here's the same thing, just represented probably a little bit neater. Remember, Pythagoras' theorem is a squared plus b squared is c squared. And the most important thing is to know which sides are a, b and c. And then all you need to do is substitute them.
So here we've got another right angle triangle, and I'm being asked to find out the value of x, the missing side. Now I think to myself really quickly, which one is the hypotenuse? Well, I know that this is the side opposite the right angle, so therefore that is the hypotenuse. And Pythagoras' theorem, which is this formula here, a squared plus b squared equals c squared, the hypotenuse is always going to be c. So that's a really important thing to remember, and that's why I say label it, so that you know which one's a hypotenuse, because you know that hypotenuse is c, because the areas of these squares add up to make the area of that square. So let's try this one. So if I actually change this to colours, so here I've got, let's just say that A is 6. I'll change this colour too, just so it's a little bit easier. B is 8, and remember, it doesn't matter which order they're in, because A and B are the two shorter sides. Okay, so it doesn't matter which order they're in. You could have had A is 8 and B is 6, it doesn't matter. What matters is that C is the length of the hypotenuse. So we don't know what that is, so we can call it X, or we could leave it as C, whatever is easiest for you. So I know that using Pythagoras' theorem, a squared, so the square of the side length A, which is 6, plus b squared, which is the area formed by the side length of 8, will give me c squared, or this missing value. So I could say x squared or c squared, once again, whichever you prefer, whichever makes more sense to you. So what is the area of a square formed by side length 6? 6 times 6, or 6 squared, is 36. What about for this side here? 8 times 8 is 64. So I'd write that here. Or you could have written it as 8 squared. So you've got 6 squared plus 8 squared equals x squared. That's how you do it algebraically, and this is how you could do it visually. So I know that the area of these two squares must add up to make the area of the biggest square here. So 64 plus 36, that gives me 100. So my big square, and therefore x, has an area of 100. So I must think to myself, what number multiplied by itself, so x squared, something times by itself, equals 100. Alternatively, if you don't know your square numbers off by heart, you can just use the square root button. So the inverse of squaring something is square rooting it. So if you had x squared is 100. You could say x is the square root of 100. And I'll show you quickly how you can do that on your calculator. So when you've got your calculator, you have to press the shift button, and then this, oh actually no, you don't have to press the shift button. You just press that button there. Okay, so that button there gives you the square root. So you just type that, press 100, and it'll tell you what it is. Or alternatively, you might remember that 10 times 10 is 100, and therefore the square root of 100 is 10. So therefore, the value of x over here must be 10. Let's just do it algebraically for those of you that just prefer simply substituting. So you've got 36 plus 64, which is the area of these two squares, gives you x squared. And then add them together. 36 plus 64 is 100, which is x squared. And x squared means x times x. So something times by itself gives you 100. And the inverse of a square number is square rooting. So you type the square root of 100 gives you x. And what's the square root of 100? 10. A lot of writing. Let's see if we can apply it to some questions now.
And once again, just a visual representation of what I just explained. Hopefully you can see how the areas of the squares would fit into the larger square. And now let's see if you can apply this to some questions for yourself. Remember, Pythagoras' theorem is a squared plus b squared equals c squared. And start off by identifying where your hypotenuse is. Which side is your hypotenuse? That's the side that's going to be C. And finally, here are the answers with a few of the workings out as well. Remember that 6.4 equals x is the same as saying x equals 6.4. It doesn't matter what side of the equation x is on. It means the same thing. So if your answer says x is 6.4, you are absolutely right.
That's all for this video. So if you liked it, then hit like or subscribe. And if you want an explanation in a little bit more detail or something different, then just drop a comment below. Thanks for watching.